All right, hello everybody. Welcome back. I know, I said this was going to be the or last video was going to be the last video, but this is actually going to be the last video. This is kind of like a retroactive video because we talked about this We talked about this periodic trend stuff in class earlier today or last week, and there are just some things I kind of want to go over again and sort of clarify with this video. And just make sure everyone's on the same page, especially because I want people to be able to study for the upcoming test. So the first of the four trends, right? Because again, periodic trends are talking about trends across the whole periodic table, right? So what happens to these different things as we move from the left-hand side to the right-hand side across the periodic table, or from the top all the way down a row or down one of our groups on the periodic table? What happens to things like atomic radius? What happens to things like ionic radius, ionization energy, and electronegativity? And those are the four things that we're going to be talking about today. So let's start here with atomic radius. And again, the biggest thing I want you guys to kind of understand and know about atomic radius comes from the actual trend itself. Okay, it's one thing to know that atomic radius refers to the distance from the center of the atom to the outermost electron. Okay, that kind of makes sense to everybody. And in a second here, I'll show you a picture of what atomic radius looks like. All right, but the biggest takeaway I want you guys to know are these things here. Okay, these bullet points here. All right, probably the most important of all on this particular slide here. As you move from the left to the right on the periodic table, atomic radius is going to decrease. Okay, decrease. I'm going to highlight all this stuff here, okay, because it's really, really important you guys recognize those. So the same thing over here, okay, the other trend. So for each one of these trends, it's essentially two sections here, okay? And then as you move from the top to the bottom on the periodic table, okay, so something like this. So from the top down, okay, from the left to the right, okay, that's essentially what we're referring to. Atomic radius for this is going to increase, right? So we're going to increase. So this is a decrease. This is an increase. Okay, so again, as you move from the left to the right, you're going to see a decrease in atomic radius, and as you move from the top down a group, you're going to see an increase in atomic radius. So let's look at some pictorial examples of atomic radius. So guys, this is an example of two different atoms here, okay? This is atom number 1 right here. Okay, and this is atom number 2 right here. Okay, oopsie, number two. So right here in the dead center of each of these atoms are the nucleus. Okay, it's the nucleus of each one, and the circle around it is the outermost electron, right? Or one of our valence electrons, our outermost shell. So that distance between the nucleus in the center and the outermost electron here, okay, this is your atomic radius. So the distance that's covered between where your nucleus is in the center right here and the outermost electron way over here, this is your atomic radius, right? And that's kind of where this comes into play here. Okay, that little stretch right here is the atomic radius. Okay. So moving from atomic radius now is this table S here. And guys, table S is actually really, really important and really convenient to have. It gives you a ton of information. It kind of like all really in a nice, concise table puts out a ton of great information like the atomic number, the symbol, the name of that element, right? So a ton of really, really great, great and useful information. But more importantly, it also gives us the values of atomic radius for all of the elements in the periodic table, okay, or at least the majority of them. There's a couple of breaks in this table that don't show exactly every single one, all right, but it gives the atomic radius of a majority of the elements in the periodic table, and it's super, super important to know these values and know where to find them too, because it's going to play into these trends. And as we go from the left to right, does it actually increase the atomic radius or decrease the atomic radius? Yes, it does, and you can actually find that based on the actual values right here on table S. Okay, and this will be important too, especially when we're talking about the trends on the test next week, okay? So moving on to ionic radius. Now, ionic radius. And really the main takeaway here for ionic radius needs to come from this bullet point right here, okay? Comparing to the atomic radius here, okay? Compared to the atomic radius, the ionic radius is smaller for positive ions. And for ionic radius, it's going to be larger for negative ions, okay? So this whole section right here is really, really important. So please, please, please do your best to mark it in some way, shape, or form as being such, as being very, very important, okay? You can write the word important, you can highlight, underline, circle, asterisk, star, whatever you need to do to make sure this is important, okay? Because this is the trend I need you guys to know and understand for next week, okay? Here's a great picture representation of that comparison between atomic radius and ionic radius and the difference between a positive ion and a negative ion in the bottom here, okay? So let's dissect this real quick. All right, so our first example I'm going to look at here is our example of sodium here. Okay, draw a better circle this time. There we go. Okay, so sodium here. Sodium here, this example here, I'm going to very carefully draw my circle of right here. This is an atom of sodium. This is an atom of sodium, whereas this right here is an ion of sodium. And the reason why it is significantly smaller, okay, this ionic radius for sodium is smaller, is because of this positive ion here. Because this is a positive ion, positive ions, the ionic radius is always going to be smaller than the atomic radius, okay? Because it is a positive ion. Again, positive ion, smaller. Positive ion, smaller. That's the biggest takeaway here, okay? Now, if we erase some of this crap here, let's go through that. Erase, erase, erase. Bear with me here, please. Okay, positive ion, smaller. Now let's look at the bottom here. The ionic radius of a negative ion is larger. Okay, larger, larger, larger. So if we compare, looking at fluorine now, our example of fluorine, okay, this right here is an example of fluorine. On the left here, okay, this example right here is actually an atom of fluorine. Okay, the 71 ppm, picometers, PM is picometers, 71 picometers, that is the atomic radius of a fluorine's atom, okay? But since fluorine ends up becoming a negative ion, negative ions end up being larger. Negative ion, larger. Negative ion, larger, okay? So this right here, this circle, this sphere here represents a much larger negative ion of fluorine, right? Negative ion here, okay? And you can very clearly see that negative ion right there. I just drew over and I'll delete it there. Okay, so negative ion of fluorine, 119 picometers, right? And the same deal here over for chlorine, right? Chlorine's atom is 99 picometers, whereas chlorine's ion, negative ion, is going to be 167 picometers, so much, much, much bigger. All right, on to ionization energy, and these next two are going to kind of be short and sweet, okay? So ionization energy is the amount of energy required to remove the outermost electron from an atom, okay? And again, as important as the vocabulary is here, the definition of ionization energy, my biggest thing I need you guys to know and understand is this right here, okay? This bullet point right here, and this bullet point right here, okay? As you move from the left to the right on the periodic table, ionization energies increase. So from the left to the right, okay, we're going to see an increase. Increase from left to right, okay? And as you move from the top to the bottom on the periodic table, ionization energies are going to decrease this time around, okay? Decrease this time around. So, definitely a different trend here than what we're used to seeing with the atomic and ionic radius, okay? So from the top down, okay, we're going to see a decrease this time. Decrease. Okay, decrease. Okay. So that right there is showing a decrease. Okay, increase from left to right, top to bottom is going to be a decrease for ionization energy. Okay. So now electronegativity. Okay, electronegativity is a little bit of a different type of thing here, right? Another different trend we're going to talk about here. And electronegativity is the tendency of an atom to attract an electron on a scale from 0.0 to 4.0. Okay, and out of all of the elements in the periodic table, fluorine is actually the most electronegative. Okay, and when I say it's the most electronegative, I also mean that it happens to be, oopsie, it happens to be, what is going on here? Exit drawing. No, there we go. Hello? There we go. Okay, so fluorine. Okay, fluorine actually is the 4.0 on the scale. So fluorine's electronegativity here, okay, if you were to actually find this on table S here, table S was that table S, or that table I showed you guys before, okay, it has a value of 4.0. It is the highest electronegative, it's the most electronegative, has the highest electronegativity of all of the atoms in the periodic table, okay? And again, it's listed right here on table S right there, okay, listed on table S. But again, the more important thing I need you guys to take away is, of course, the trend itself, okay? And we're going to once again look at these last two bullet points right here, because these last two bullet points have the trend themselves. So as you move from the left to the right on the periodic table, electronegativity is going to increase. So as you move from the left to the right, we're going to increase. And as you move from the top to the bottom on the periodic table, electronegativity is going to decrease. So again, slightly different here than what we saw previously. Left to right is going to increase electronegativity, top to bottom, down one of our vertical columns, one of our vertical groups, okay, electronegativity is going to decrease this time around, okay? So again, a little bit different, okay, decreasing electronegativity. All right, so electronegativities, this is kind of like an overall picture of it, but I'm going to skip this. Metallic character, I'm actually going to just skip that as well. So this right here is actually a really, really great slide. It has all of the trends I had you guys highlight and kind of mark as important on the last few slides, all in one nice, concise little spot here, okay? So you can see right here, just by looking at each of the four quadrants here, each of these four pictures, we're talking about atomic rays in the top left. We're talking about ionization energy right here. We're talking about metallic character, which again, we're not really focusing too much on. And we're going to talk about electronegativity right here. And those arrows represent all of the different trends here. Generally increases, generally decreases, etc. Okay, so use this slide to help you, as well as that make your own periodic table trends packet we worked on the other day in class. Okay, so that's kind of it here, guys. That's all of chapter 9 here officially done and dusted. So we obviously have our test in a couple of days here on Wednesday, the 1st of November. So make sure you guys study up. And yeah, good luck.